Hey, Science 10, we're going to do some kinetic energy, specifically calculating it. Make sure you have a calculator. Make sure you've got your physics formula sheet. And yeah, let's get underway. Have your note paper as well, of course. And kinetic energy, it's the energy of motion. So once something is in motion, of course, you first have to put energy in. So yeah, this bike is moving up the hill, but what we want to think about is it takes energy to get up there. It's right at this point, it's got potential energy. So, we're building up some potential energy. It's right there, and then boom, energy out. With the baseball bat here, the person hasn't swung yet, right? So there's all that potential energy in the muscles. As soon as it starts moving, now the energy is coming out of the muscles and the bat is moving. Here's the ball coming towards it. So yeah, you don't want to think about getting hit by that bat, but that would be kinetic energy. Kinetic energy is there. It's energy of motion. It's not just sitting at the top of a hill, potential energy. It's being released, right? So there's some factors. We'll talk about it. And yeah, let's start with that right now. Let's start some notes here. Kinetic energy, energy of motion. You can see the formula there on the side, but yeah, definitely get this down in your notes. It's a good way to internalize what you're learning. If you think about it, and actually we've got it right here, just kind of scroll up a little bit. So, depending on what's traveling towards you, if it's a baseball and, doesn't have much mass, but if it's going really fast, it's got a lot of kinetic energy versus a bowling ball, right? So a baseball may be just kind of thrown slowly at you, it's just going to kind of hit you. You're going to definitely feel its kinetic energy. But a bowling ball thrown at you at the same speed, bowling ball, I'm sure most of us know, it's got a lot more mass. So that's going to hurt a bowling ball. So think about it that way. It is that energy of motion, and there are those two factors. And yeah, let's start with the bat here. The bat is now being swung, so we'll pull this down. So the bat is in motion. Okay, you can see the ball coming in. It's actually a pretty cool shot we've got going here. So the bat is in motion, the ball's coming at it, but how much kinetic energy is in that bat? So we've got a moving bat. Okay, some of the key factors. How much kinetic energy? Well, first of all, the mass of the bat. Again, if you think about it, especially in the superhero movies, when they swing something gigantic, that takes a lot of energy to swing something gigantic versus just, a little tiny, whatever, I'm going to swing a little pen. This still takes energy to swing this little pen, but doesn't appear to have much kinetic energy because, yeah, it doesn't have much mass, and also I'm not moving very fast. There's the next factor, the speed, right? So the mass of the bat, actually, let's finish this first factor. Mass of the bat. This particular bat is 1.40. So to 3 decimal places, or to 3 significant digits, I should say. Kilograms, 1.40 kilograms. Always express mass in kilograms for the kinetic energy formula. And second, the kinetic energy, it's the energy of motion, so therefore speed, which we represent, or we use V for. So the speed of the bat, those two factors put together, multiplied together in a formula, and you're going to see that in a moment. Again, this particular bat is being swung at 12.0. Again, getting pretty exact, 3 significant digits, meters per second. Speed and also velocity, always expressed in meters per second. So our formula, which you got to look at there before, and of course you got your formula sheet, so you should definitely look it up. In fact, press pause and make sure you can find your kinetic energy formula on your formula sheet. All right, you're back. So EK standing for kinetic energy. To calculate kinetic energy, we take 1/2, Okay, so it's a number we put in. 1/2 times mass times velocity squared. In other words, velocity times velocity. You'll see this written with the little hat sign in the notes. That is a way to show exponent, right? So v exponent 2 or v squared, you know, put the exponent up there. Or what we're saying is whatever velocity is times by itself, right? Whatever number, the number times itself, not times 2, remember. Be careful with that. Always focus. Always respect those exponents, what they say. Well, so let's calculate this one. This is our given information right here. We got our given information. We got a mass of a bat. So this bat is actually in motion, and it has a mass of 1.4 kilograms, and it is moving at 12 meters per second. That's pretty quick, actually. So it's being swung fairly heftily. So our given required, well, that's our required information. We're going to find our kinetic energy, some analysis, and solve it. We know that's the formula. So we'll just we'll just jump right into solving this. So the kinetic energy of this bat, well, 1/2, we got a half, times our mass, 1.40 kilograms. Definitely go ahead and pause it at this point, because I think you can kind of see how to plug these numbers in, and or just watch how I do it, then hit pause and calculate it yourself as well. Okay, so mass times velocity squared, in other words, 12.0 meters per second times 12.0 meters per second. All right, let's pull the calculator up and plug those numbers in. Whoops, oh, just a gigantic calculator. Sorry. Let's get the computer working sort of how I want it to work. 1.4. Oops, start with a half. You don't have to, obviously. It's all multiplication, but it's good procedure. Okay, half is 0.5, right? So 0.5 times 1.4. You don't need to put the 0 because it's just a 0. Times 12 times 12. Let's see what we get here. Yeah, 100.8. Now, I don't think we have 4 significant digits, but let's put that out as our answer. That's how many joules. Kinetic energy is expressed in joules. 108, because energy is expressed in joules, 0.8 joules. But yeah, we only have 3 significant digits if we take a look. 3 there, 3 there. So in other words, we stop right there at the third. So it's either rounded down to 0 or rounded up to 1, right? So it's either 100 or 101, and looks like we rounded up, right? 101 joules of energy in that baseball, or in the bat. That's a fair bit, actually. All right. Well, so let's just do a different sport. Let's not talk about a bat in motion. Let's talk about a tennis ball, right? So you're out on a tennis court and you've decided to run across it. Meanwhile, someone has shot the tennis ball right at you. They didn't mean to. So let's see how much kinetic energy you got coming at you here with this particular tennis ball. That's actually the approximate mass of a tennis ball. So yeah, to calculate kinetic energy, a reminder, you know, I need to know the mass. So here I've got something going to hit my finger. I need to know the mass of this pen, and I need to know how fast it's going. Those 2 factors, really. But yeah, let's look at this. It's written down here, but yeah, let's copy it out. Mass of the ball, 0, always expressed in kilograms, 0.0577 kilograms. So fairly accurate. That's the 4 significant digits. Speed, or in other words, v, velocity of the ball, 69.52. That sounds really fast, boy. You're definitely going to need to duck when that comes by. Meters per second. This must be for professional tennis players. Your formula for kinetic energy. It's good practice to write these out a few times, right? To also think about it, but think about those are the two key factors, right? Mass and velocity. Okay, energy of kinetic, EK, that's how we say it, kinetic energy, EK. 1/2 times mass, okay, those are my first factor, times velocity squared, so it's going to be 69.52 times 69.52, right? So always process that and think about what that's telling you. Let's go ahead and solve this. Let's plug our numbers in. EK, kinetic energy. Say it as you write it too, right? Definitely pause the video and go ahead and calculate it. We'll go 0.5 times 0.0577 kilograms times 69.52 meters per second, but it's velocity squared, so 69.52 meters per second. When you're doing these, don't rush, do them slowly. Excuse me. Look at what the formula says and follow it, basically, right? You know, again, this is our given information. We've got these two numbers. We're trying to find this third number. We're trying to find how much kinetic energy is coming at us here. Okay, we get the formula written right on this interesting slide here, so that's pretty cool. Let's get our calculator going on this. Pull it up. Get clear. Okay, so it is 0.5, always that half. And then the mass, okay, 0.5 times, yeah, I got it. 0.0577 is what they say the mass is, times 69.52. Here's the first, here's velocity, and velocity will square it, times 69.52. The nice thing, multiplication, you can write the whole sentence. You don't need any brackets, you just go for it. That indeed comes out to 139.4329. Okay, again, we're not going to need that many significant digits, although it looks like I think there's going to be 4, up to 4, right up to the 4. But yeah, let's write this out. And again, I'm sure this is what you got. Make sure your calculator is giving you the right answers, by the way. This is also good to check that. 139.4329. Okay. We do not need this many significant digits, but we've got 1, 2, 3, 4 there. We don't count that leading 0. And we've got 4 there, so 4 significant digits, the 4th, so it's going to stop right there. We either round it up to 5 or down to 4. Looks like we go down to 4. 139.4 joules in the tennis ball. Wow, that's a bit more than that bat. That's a good pro player. Hey, let's just keep doing some problems here with some kinetic energy calculation problems. Let's do another one. Talk about a plane here. Oh, not a plane yet. It's the car one first. Okay, so we got a car. It's got a mass of 1,500 kilograms, moving at a speed of 14 meters per second, so that's about 50 kilometers per hour. Got to calculate the kinetic energy. Okay, use grasp. I'm going to get started, but you start. Given, required, analysis, solve. Go for it. Hit pause. Okay, given. What information is given? What's required? I always like to start with these two. In fact, I usually, if I can, like to see what's required. What's the question asking? Okay, kinetic energy. Find kinetic energy. Could start looking on the formula chart already for that. I mean, ultimately, it's good old EK, right? Okay, let's see some of the things that we know. We know a mass here. Got a mass of 1,500 kilograms. We got a speed or a velocity. Well, it's actually not a velocity because we're not given a direction, so it is just a speed. But you know, It is a V, right? Speed is represented with the letter V. 14 meters per second. Going pretty quick. That's a big distance in a second. So this car definitely has a lot of kinetic energy. Do not get out in front of it. EK, do we know EK? No, that's what we're looking for. Unknown number of joules. Again, energy is always joules. Energy is always joules. So our analysis, and then of course we solve it. But our analysis, what formula? Yeah, we're looking for kinetic energy. These are our variables, so definitely that's going to be the formula right off the formula sheet. EK equals 1/2 times whatever mass is times velocity squared. So the velocity times velocity. Jump right in and solve it. 1/2 times, again, hit pause. Go ahead and solve it. Note how many significant digits. Looks like it's only going to go down to 2 significant digits once you, get the full answer and then round it. But let's finish this off here. 1/2 times mass, 1,500 kilograms, and now our velocity squared. Again, slow yourself down. Make sure you're following what the formula says. 14 meters per second times 14 meters per second. Let's get the calculator out. Let's go clear, clear, clear. 0.5 times my mass, 1,500, times velocity again. Big number. Definitely not going to need that many zeros because we wouldn't be that exact. Equals 147,000 joules. We only need to go to 2 significant digits, so this is either going to be round up to 5 or round down to 4. Obviously, it goes up to 5. Okay, so 147,000, we're saying it's 150,000, but we don't have that much accuracy because this is actually technically saying 6 significant digits. And you only sort of, it's about 14 meters per second. Remember, this could mean it was going maybe 13.6 or something, or could have been going 14.4. So it's really not a very, it's a fairly large range. So we can't actually be this accurate. Now we just changed it into scientific notation, right? Just to show. Okay, so you're gonna kind of wonder what I'm doing, but you'll see it. Okay, 1.5, that's 150,000 times 10 to the 1, 2, 3, 4, 5. Just count, put the decimal place right there, and then count 1, 2, 3, 4, 5, 10 to the 5. 10 to the 5 is 100,000. So it is 1.5 times 100,000. You can check this on your calculator and definitely do that. This means 10 to the power of 5, right? 10 times 10 times 10. The nice thing about how many the number there is how many zeros, right? So 1 followed by 5 zeros. Oh, 100,000. Oh, one, yeah. Type that in. I mean, you know it in your head. 1.5 times 100,000 is 150,000. This is just another way to write 150,000, but it's less zeros and it's more accurate in this case because we are showing, we only know 2 significant digits. We do not, it is not exactly 150,000. There's no way because this was not exactly 14 meters per second. If it was exactly 14 meters per second, there would have been, a whole ton of zeros, but there wasn't. So just a reminder what the whole significant digits thing is all about. It is so that we are more accurate in our answers. Joules of energy. For the car. Of kinetic. Gotta get that in there, sorry. It's in motion. Kinetic means it's motion. Let's do another one. These are too fun. As soon as it comes up, hit pause, read it. Use grasp to solve it. Okay, you've read this, so you got this fast jet plane Okay, that's cool. But we got a speed, 500 kilometers an hour. Oh, we got to convert it to meters per second. And the mass, 3,000 kilograms. Okay, so we got a speed and a mass. We want to find kinetic energy. Okay, so let's get this going. Given, what information are we given? What are we required? Again, double check this. Don't rush into this, right? Look carefully. I really do, if I can, I like to put what it's asking. So find kinetic energy. And okay, so what information are we given? We got a mass, 3,000 kg. We got a speed, but it is in kilometers per hour. It has to be in meters per second, or V, right? At the V. 500 km, which stands for 1,000 meters. 500,000. So yeah, that's 500,000 meters, or 500 kilometers per hour. Okay, let us convert this, right? Do exactly what it says. 500,000, because that's what the K says, meters per hour. Well, you got to convert hours into seconds, right? Because we got to go meters per second. There's 60 minutes times 60 seconds. Let's just kind of do a little rough work off the side here to convert hours to minutes. Just do it up here. 60 minutes times, and there's 60 seconds in 1 minute. So this is going to be how many seconds in 60 minutes? 6 times 6 is 36. This is, and then add the 2 zeros. 3,600 seconds. Okay. Try it. Go ahead. Spend an hour counting. Yeah, don't. $3,600 seconds. Okay, okay. Whew, wow, okay. Analysis. And then we're going to solve it. Plug the numbers in. Analysis, we get our formula. You might have already written down the formula, which is fine, right? In fact, probably should write it down almost as soon as you can so you can start focusing, slow your mind down and say, hey, I know what formula is going on. But it is a kinetic energy formula, EK. And as many questions as you do each time, write the formula out and tell yourself what it says. 1/2 times mass. Okay, that's a critical factor in kinetic energy, mass. Times velocity, but you got to square that velocity because there's a lot of energy there. Ultimately, this is telling us there's a lot of energy there. Let's plug it in. Let's solve it. EK equals 1/2 times our mass of 3,000 kg times, oh, yeah, we want to get this answer here. I was thinking I had my meters per second. I don't. 500,000 divided by 3,600. Okay, clear this off. 500,000 divided by 3,600. 138. Now, don't round it yet. You're going to think, oh, I got to get the significant. No, not yet. We're still in calculations, right? So we're still calculating. We haven't got to answer. So do not round yet. So 138.88 forever, basically. 138.8 forever meters per second. It's pretty darn quick. 138.8 forever times 138.8 forever, velocity squared. Okay. You pause, you try it. I'm going to do it right now, show it to you too. Let's clear this off. Okay, 0.5, so half times 3,000 times 138. Point. How many 8s do you put in? Put a bunch. Times 138.888. As many as your calculator can hold. This thing can hold way too many of those. So, okay, that's big, but it's basically 28 million, almost 29 million actually. That's a lot, but let's put it out here. And I've got it written down here handily for me. 0.184. 28,935,000. Obviously, it's not going to be this exact. We do not have this many significant digits, but still write out the whole number, just for laughs even. Like, hey, this is fun. 0.184. We, again, do not need this many significant digits, but it's just to show ourselves, yeah, when we got, you know, the exact answer, but again, we can't actually be this exact because let's just check the question. How many significant digits? 3 is the most. So we need to stop right there at the 9. We're definitely going to need to use scientific notation to write this number. So it's going to be 2.89 times 10 to the whatever. But let's focus on the 9 here. We either round it up. Well, okay, so 90, we'd round it up to 90 or stay at 89. Well, we look right there, the 3, so we stay at 89. 2.89. Now remember the trick to do this. Times 10 to the 1, 2, 3, 4, 5, 6, 7. 10 to the 7. Now 10 to the 6, I just happen to know this. It's kind of one of the cool things that I like to remind myself. 10 to the 6 is a million, right? Like a 1 followed by 6 zeros. That's a million. Or another way to write that is 10 to the 6. Oh yeah, 1 followed by 6 zeros. That's the pattern in exponents, right? Think about 10 to the 2. That's 100. 1 followed by 2 zeros, right? So this 2 is followed by 7 places, right? 1, 2, 3, 4, 5, 6, 7. Yeah, it is. This is 2.89 times 10 million. You know, so basically 3 times 10 million, yeah, that's 30 million, 28 million in this case, joules. Of course, we didn't round it to 30. We rounded it to 3 significant digits, 2.89. A good reason to put your full number out there from your calculator is to make sure that you've got, you know, that you've rounded it correctly. Don't just type this in once into your calculator. Do it, you know, 2 or 3 times at least, right? Okay, last one. Let's do one more, calculating kinetic energy. Again, read it, use the grasp method. I'm going to get going as well. Hit pause though and see if you can solve it. And yeah, let's take a look at it. Okay, what information are we given? We got a wrecking ball here. Yeah, it's similar to one shown. It's got a mass of 315, okay, big mass, and it's moving at a speed of 5.12 meters per second. What's the kinetic energy? It's kinetic energy is being released here. That's a good picture, actually. Analysis. In other words, what formula do we use? And then solve it. Just plug in the numbers. Let's get some of those numbers out of here. Looks like we're looking for kinetic energy. Might as well put the formula out, right? 1/2 times mass times velocity squared. Let's see what we got here. We have m, 315. Hey, we can start plugging this stuff in. Still write it out. Write it out so you can check it, so you can check your work. Mass, a v, a velocity, a speed, 5.12 meters per second. Do I know kinetic energy? Nope. Unknown number of joules. That's in fact what we're looking for. Well, let's just plug it in. Kinetic energy of this wrecking ball, 1/2 times its mass, 315 kilograms, times its velocity squared, 5.12 meters per second, times 5.12 meters per second. Okay, when you do that, and I'm just going to skip showing my calculator, we get 4,128. Again, I don't think we're going to need this many significant digits. 768 joules. Let's look at the question though now, because we don't round to the end. Do try to write a little bit neater. 3. Okay, 3 significant digits. We're going to stop right there. It's going to be Well, we're going to have to use scientific notation. Okay, so it's going to be 4.12 or 4.13. Looks like it would be 4.13, right? 4.13 times 10 to the, we got to multiply 4 by 1,000, right? So 10 to the 3, or we got to have 4 followed by 3 joules. There we go. Okay, awesome. There's more practice questions in the notes and also the textbooks. You're going to want to do a bunch of these. You can do the same questions though over and over a couple times to get the process. That is actually the best way to practice, is actually take these exact questions I've just given you and practice them again and again to get the process. What's given, what's required, analysis, and solve it, and then boom, you get the answer. Okay, Science 10.